Hi everyone, welcome back to my Rust programming language series. In this video, we're gonna go over data types. We're gonna go over scalar data types and compound data types. Just gonna cover some stuff that is probably specific to Rust and not gonna spend so much time on explaining concepts that are similar in any other programming languages. So in the types in Rust, let's go with like simple stuff like integers, right? So the integers are very similar to what you're gonna see in some other languages. So Rust has, I8, I16, I32, I64, and that's basically unsigned integer. The equivalents in, sorry, this is the signed integer. The equivalents in unsigned are basically I8, I16, I32, right? Um, so there's no surprises there. Oh, one thing you want to know about it is about how overflows are handled here in Rust. So if the overflow is met in debug mode, you'll actually get a panic. In release mode, you will get by default you get the regular overflow. So the behavior is just gonna be like wrapping around integer. So once you go above max, it's gonna go back to the minimum number, and keep going like this. You can actually force the behavior that will happen during the overflow. So they have this like methods like wrapping add. That's basically default, where in release mode this is default, right, where the wrapping happens. Then there is a saturating add, for example, and also there is an add, subtract, right, stuff like this. Saturating means that once you reach maximum, we'll go back to I think it will limit you on how far you go, right? Like the max will just stay at max, the min will just stay at min, right? When you can go further than that. Then there's one checked add. I think when the overflow happens, you'll get none as a result. And the last one I think is overflowing add, right? Where I think you'll get a value something like the number that is overflowed, and then there is a bool, right? Whether the number was overflowed or not. So yeah, so nothing surprising there. Same thing with bools. Nothing new there. One thing is interesting is that char is actually chars in Rust actually use single quotes, right? Something like this. And one interesting thing is actually the chars in Rust are 4 bytes because it's in Unicode. So that's one thing, and I think that's it for the scalar types. There's nothing new there. The compound types are two compound types, a tuple and array. Again, nothing too crazy there. So you can say, let let's say let tup, right, and then 4, 4, 4, 4, right, like hello, and 2x is the tuple. You do let's do println tup. You do that and then the index. So let's say we want to access index 0. So we say it this way, cargo run, and I messed something up. Oh, I guess I did. Yes, I did. We actually have to, let me see, my lovely tuple, right? Okay, here we go, we got my lovely tuple 45. There's also, if you're familiar with C++ structure bindings to extract tuple values, you can also do stuff like this. Let x, y, and z equal tup, and I think we should be able to do this. Hello, x is x. So this in Rust called destructuring is when you actually expand tuple into this values. So now you have like x is equal to 45, y is equal to 443, and z is hello. The language is like C++ called structure binding. So let's just make sure I didn't mess something up, and I did. Oh yes, trick myself now. There you go. Unexpected token. What did I mess up here? Oh. Right, yeah, so we unuse the variables y and z, so then the compiler tells us, right? If it's unused, you want to make sure that you put the underscores in front of the names. This is not an actual error, but you know, compiler just tries to be strict to make sure, which is good. Okay, so now we can see our hello is 45, right? So there are two ways to do it, either by index or by using the structured bindings. Then there's an array. Array is literally the same thing that you see somewhere else, right? You get a fixed size array, and then you do stuff like this. Indexing works the same way, where you just go like stuff like this, which is similar to other languages, so there's no point covering here. As some of you know, array is actually on a stack. So when you know the size of the data like ahead of time, and you know it's small enough, might as well just use array instead of vector. When you're not sure, use vector. We're gonna cover vector in the future videos. Alright, I hope you guys like this video. Thank you very much.